Guys, I'm super excited about this. This wire, revolutionary. Hey, good morning. It's Joel Walsman, CEO and Master Electrician of Jefferson Electric, and today I'm at Sean Staley's house. Sean is employee number 2 at Jefferson Electric and project manager. As you know, we've purchased Teslas for our PMs and estimators because of the incredible efficiency of driving an electric vehicle, and we're going to dive into that, and it's going to blow you away today. No joke, absolutely blow away. But interesting to note, I actually worked on this house back when I was an apprentice with the master electrician who trained me. So I worked on this house like 12 years ago. And then one of Sean's first jobs was at this house as an apprentice with me, installing exterior lights and three-way switching. And then, like what, a year ago, Sean?
2 years ago.
2 years ago, man. Sean and his wife bought this house, and he's walking through the house and he's like, wait.
I was walking through and everything seemed familiar, and then I pulled away this couch and I was like, I installed that doorbell ringer. I know this house. I've been here.
That's hilarious. We've been all over this house. We've done kitchen remodels, master suite remodels, just all kinds of stuff. And so today we're going to add an independent service for electric vehicle charging to take advantage of a special electric vehicle charging rate. So, Sean drives about 20,000 miles a year as an estimator and project manager at Jefferson Electric. The electric cost to us is going to be about $200 for all of that charging through this special program. So let's see how we set that up. Let's dive in. Sean, want to walk us through? So what are we looking at back here, Sean?
Okay, so we have to trench from that pole to the equipment rack by the shed there. And I was thinking, these are blocking us here. We could try to go that way, but then we're going to be blocked by the stump, so I'm thinking we come out, stop, and then cut straight back from there. Okay,
so brand new 200 amp service coming off the pole, cut through your yard, up to the H-frame or equipment rack, and this has already been approved by the utility.
Yes,
you've had a meeting with the underground residential engineer, so this is an approved project. We've got permits, self-certification. It's time for installation.
Yep.
All right, so we've got all the materials laid out here right by the job site. Only handle them once, we're ready to go. We've got our strut. Dang it, I forgot the cold galvanizing straight for the cut ends of the strut. I had that on my mental list. Should have written it down. We've got our post rack. We've got our Schedule 80 conduit. It's all going to be subject to physical damage, so Schedule 80 PVC for us. 2 ground rods. We've got the 200 amp meter cabinet. NEMA 1450 plug. Box of parts. Here's something that's kind of interesting. We are using expanding foam, Sika post fix, instead of quick set concrete like we usually have. I have not gotten to use this yet, so this is the first look for me. We've got our various types of wire, and this one right here, I'm super excited to show you about this. This could revolutionize some of our projects at Jefferson Electric. So more about that in a minute. Grounding wire. We've got our totes. We've got our outdoor 200 amp main panel. We've got surge protection. We've got our canopy. Hey, one of you, and I forget what your name was, but you recommended a canopy to protect our tools and ourselves from the inclement weather. We listened. Thanks so much. This is a 10 by 10. It was like 150 bucks. Golden. I'm really excited about using this today because rain's supposed to set in at 1. And then of course we have our earth moving tools, and the trencher is going to be showing up in probably under 45 minutes. So, woo! Let's go! We've had so much pain and suffering being electricians and earth moving for underground services, power to outbuildings, and things of that nature. If you'd like to learn from our pain and best practices, check out the video here. So it wasn't a competition, but we're making it one. So right now we're digging holes that are 36 to 48 inches in depth and about 10 inches across in order to set our H-frame rack. We're going to have 2 galvanized IMC, that's an electrical conduit, IMC conduits that are going to comprise our rack. That rack, again, is specified in detail by our utility company, so check with yours for their detail. This is going to be our utility rack. It's going to have our meter and our electrical panel. Our EV NEMA 1450 is going right here on the side of the shed. Our trench path is in this direction, past the play set in the backyard. around the guy wires, and to the electric pole. So I have yet to use this product. This is Sika Post Fix. I hope you guys are watching. Send some love our direction. But this is equal to 2 50-pound bags of concrete. It weighs, gosh, I don't know, less than a pound. It's an expanding foam. So one bag should fill this entire hole, sets in under 2 minutes, and then it's ready to install the racking in under 2 hours. It's pretty sweet, with no bracing required. Let's give it a shot. You're live with me. Burst seal. It just says burst seal. Come on, buddy. There it is. That wasn't that hard. All right, 15 minutes of rigorous mixing.
15 minutes?
Seconds. I meant seconds.
Boy.
Pour it evenly in the hole. Sean's watching the level. Man, there's no way. There's no way. It's like the tiniest little puddle in the bottom of this hole. There's just no way. I can't wait to see this.
That was pretty ridiculous.
Yeah, it's gonna have to expand like 200 times. And then what's its density and strength after that? I feel like
Great though.
Yeah, I feel like I've been had. It's probably like every air pocket is a perfect honeycomb, and it's of incredible strength. Man, I just can't believe that.
That's how they set.
All right, it's time for the equipment layout. I'm gonna build what's going on the rack over here, so that as soon as that rack is hardened up and ready, we can just whoop, U-bolt it. I'm gonna get it wired in and everything. Always producing, right? I'm not waiting around. That trencher should be here any minute. All right, so that's my cover. Here's my panel. Get that door lifted off so it's not in my way.
I'm not sure.
Yeah. Yeah. Get my phone, Joe.
Yep.
Hey, Tesla, just pull into the garage real quick.
Excuse me, Tesla. Oh, dang, you got the big one. That's gonna be tougher to fit.
I know. It's huge.
I said the biggest walk behind.
Oh, did you say walk behind?
Oh, sorry. I told Doug not you.
Is it the yellow one, just the Vermeer?
Yeah.
I thought we always got that one for...
Well, except for tight spaces.
Yeah, it's not a very long trench. You're right. Now this is important because we've got a metallic fitting in the service equipment. We are installing a bond bushing. Now here's the deal. Our utility company does not allow a ground in the meter base. Only the grounded conductor, that's the neutral, and that's where the bonding takes place. No ground wire. So I've got to put the bond bushing on this side. And if you're one of my apprentices watching this video, please pay close attention. Metallic fitting, bond bushing. If this was PVC, there'd be no bond bushing. There'd be no requirement to continue an electrical path, just a mechanical path. So we're definitely getting that bond bushing on there. We're going to take a bonding jumper from the bushing to the ground bar. The bonding jumper gets sized according to the service.
At least we can go deep, and if it rains, it'll still be to depth.
If you've got another method of tightening up large lock nuts that you really like besides the hammer and flathead method, let me know. You must note, you absolutely have to have a lock nut. Can't just have a insulating bushing, and you absolutely have to have the insulating bushing. Our inspectors and our utility company will ding you if either of those fittings are missing. 30 inch. That's gonna be the length of my strut. There's no fast way of doing this, but you don't want to be too fast and make mistakes. Just need to be methodical. Sometimes I struggle with that. All right, so I'm gonna cut both pieces of strut at once if my atomic can handle it, my little bandsaw there. And we're gonna cut it to 30 inches.
I would back up here and then pull forward a little bit more in the direction you want to go. Bring it up.
And that's right here.
It's not easy to turn with that.
And I think I'm okay with that. No, the atomic will only do one at a time. Poor guy.
Yeah, we're gonna go, and then we'll just do one like cross.
Let's think about this. I'm gonna look at the U-bolts, which are in here. It's gonna come up. Yeah, I'm gonna cut it one more, one longer.
Just got past.
The utility company, as I've said all along, they're going to prescribe the parameters of this installation, their engineering department. That's coming from them according to their Gold Book standards. We've got two options in this case that they gave us. We could use 4-inch Schedule 40 conduit and bury it in the trench, or direct burial cable that's real heavy jacket rated for going right in the earth. We're going to use direct burial cable, partially because our trench is going to be sliced and diced a little bit to maneuver its way back here. Maximum degrees of bends in a trench with the utility company, 270. By National Electrical Code standards, 360. The utility company also requires sweep 90s. So they're great big old, like literally 36-inch radius 90s. And PVC is through the roof right now on cost. So that would be at another about $800 to this project to put it in conduit versus direct burial, as well as labor. So in the final analysis here, this U-bolt is going to be through the back of this strut. About like, whoo, it's a little tight with the nuts on there. Come on. Come on, baby. Ooh, ooh. It's a little persnickety, honestly. I'm going to have to splay it out. U-bolt's going to be through the strut, and I can't mount the equipment because I got to be able to get to the nuts and tighten them down. And so I'm getting things dialed in for the prefab, but I really can't have them permanently mounted yet. I prefer cone nuts over spring nuts quite a bit because of this reason. These spring nuts keep popping out, but they cone nuts are more expensive, but man, I think they're probably worth it. Think about ready to make the switch away from spring nuts. You know what I'm gonna do for these? I'm going to drill an intentionally oversized hole for mounting purposes, and that's going to be like a 1/2 inch. I'm putting a big old washer on my bolts, so there's going to be plenty of grab, but this 1/2 inch is going to allow me to be a little bit more reckless, if you will, in where I drill that hole, less precise. I am going to use the strut across the back of the panel as a straight edge, a guide. So if I line up my strut with hole number 1 in the cabinet, hole number 2, then at least I have a guide to where to put that mounting hole, and I should be in good shape. I've been wrong before. It's happened once. Woo! Reckless was right. That was crazy. All right, so a bunch of things I want you to pay really close attention to. One, the utility side is always the line side, top side. No exceptions that I'm aware of in anywhere in the state of Indiana. We're going to be required by the utility to come in the bottom left corner. We're going to put that male adapter right there, and that's so that the wire has clear entry. The utility company is required for supplying the wire and making the line side terminations. That is all they will do for us. Really important. I've got phase A as black marked on phase A, landed on phase A. I've got phase B, that's getting kind of tight right there with respect to wire bending radius, landed on phase B. And I've got neutrals marked with 3 wraps of white electrical tape on both sides. That's really important. Now it's super congested with all this big wire in here, but according to the utility program, the only circuit that can be on this is the EV circuit right here. Probably will never use those 20 amp breakers as long as the EV program is running and we're getting this awesome utility rate. Now I told you it's $200 in electricity per year to operate this Tesla Model 3 for 20,000 miles. That is 1/10 the cost of gas. That's where we're gonna make our money on those Teslas. You thought I was being spendy. Now you come to find out we're being thrifty. All right, more going on here. We've got our bond bushing. We've got our bonding wire to our ground and neutral bar. Grounds and neutrals are common in this cabinet because this is the first means of disconnect, main disconnecting means. And so we've got our bonding screw tightened down to our cabinet. This neutral bar is common with this neutral bar. We don't intend to use the ground bars on either side here. The only path of grounding is through the cabinet itself. That's not going to be good enough. So we're going to bring our grounds and neutrals right off the neutral bar. And again, this is common with this, and this is a plug-on neutral panel. What that means is it's got a neutral bar connected to the neutral bus on each side. There's a copper neutral bar that's common or connected here. So if we plug in a breaker that's got a neutral connection, requires a neutral connection, it'll plug right into that neutral. For instance, this surge suppressor, it's got a neutral pigtail landed to the neutral bar. But if it was a newer upgraded type, then there would be no pigtail terminating the surge suppressor to the neutral bar. It would be connected right through that bus. So this is called a plug-on neutral panel. Highly recommend them. All right, neutrals and grounds are common. Line side, load side, make note of everything. Wraps of white tape. We're almost ready to go. All right, so we were gonna put in an overhead service just to make it a little easier, and the utility company spec sheet requires a class 6 pole. We don't often set utility poles, and so Sean was investigating it and found out that they were out of stock, and we're gonna be delayed weeks and weeks and weeks, and so we're gonna have to bump up to the next size, which was what, Sean?
Class 7.
Class 7.
1,000 pounds.
1,000-pound pole. We're like, there's no way. We don't have the equipment for this. We don't do utility work. We don't have bucket trucks. We don't have pole trucks. So we're going underground. Ultimately, it's going to be a better product for Sean. Check out these tracks too, right? You got to prep your customer for stuff like this. Tracks in the yard. Whose responsibility is this? This will cost you, $1,000 if you hire a landscape company. Okay, $500 to $1,000 to clean this kind of stuff up. And if you're responsible, there goes your margin. What's the total cost on a project like this? All right, I'm gonna tell you at the end. So it did require more than 1 bag of foam per hole, which is more than what was advertised. So that's something to take note of. And the poles one of them did drift a little bit. Almost seemed like maybe I didn't put the foam in easily and it kind of pushed it over, who knows what. But something to make note of. The concrete's cheaper, but dude, this is a heck of a lot easier in my opinion so far. All right guys, we've been over this before, we're gonna do it again. We've got 275 inch-pounds required. We've got a foot-pounds torque wrench, so 275 divided by 12 inches per feet, and we've got 23 foot-pounds of torque required. So we're going to tighten it down, loosen it up, and then tighten it down again. And that's in order to get those fibers, the strands of the wire to all seat and mesh in there and get a good contact connection. We also wire brushed and no-loxed the wire itself. This is an aluminum alloy. Probably technically doesn't need to be wire brushed and no-loxed, but the inspectors are going to nab you. And it doesn't hurt. That's the thing. If there's any uncertainty, just do it. Just do it. So as a policy, we just do it across all aluminum and aluminum alloy wire, period, unless it's specifically stated not, we do it. All right, now you gotta check over here, see what the rating is. Torque rating, 250 inch-pounds. Back it off a bit. Now this is one of the most important things I can tell you today. Just because you have a torque wrench doesn't mean it's not out of calibration. Doesn't mean you can turn off common sense. If you over torque that terminal and blow it out, you're gonna be in it for a whole new breaker and you're gonna be in it out of your own pocket. So that's 150 bucks plus time and energy and showing up late at home because you had to run out and grab parts. That is a poorly planned project. So don't shut off your common sense just because you're using a torque wrench. Make sure the tool is calibrated as required, which often is every 5,000 to 10,000 clicks. It takes us a long time to get that many clicks just because we only use them a few times a week. But man, you gotta be careful. All right, I'm actually pretty excited about this. I just bought it, holstery, and I'm pretty curious, as to whether this is the perfect application for it today. So, it's magnetic, I'm gonna clip it on. I'm always losing hardware. I mean, what do you do with that stuff when you're working? I've got no workbench, I've got nothing. Holstery, it's just a strong magnet. It feels really durable, honestly. It feels like super, super high quality. So, I'm going with it. So far, so good. All right, I'm gonna start at the top. My top of my meter cabinet, top of my globe, can't be above 6 feet. It's between 5 and 6 feet is what our utility requires. I'm just gonna put it kind of nearish the top here, and then I'm exactly 11 inches below that to my next strut. So we get the first one set. Got my meter cabinet on the right, my disconnect, my trailer panel is what it's called, on the right. Meter panel left, trailer panel right. Did I say that? So it's kind of just a lot to hold here. All right, guys, a little bit more prep. Cut all my U-bolts down to match with the bandsaw so I preserve the integrity of the threads. I cut a solid inch, say a fair inch off all of them. If you didn't have a bandsaw, this would be a really laborious process. You'd have to spin the nut on down here, cut it with the Sawzall, which would be hard to hold because all that reciprocation really bangs the piece around, and then you'd have to pull the nut back off in order to clean up the threads, in order to take it apart, in order to mount it. Bandsaw. Guys, holstery is a winner. I'm for you. Putting a link in the description. Boom. I've always struggled with the parts and pieces, right? It's the name of the game. Holstery, you've solved my problems. Look at that. You just take the pile of hardware, you just slap it on there, and that magnet's pretty powerful. I was kind of bumping around my arm and I didn't knock anything off. I'm in the club. You could be in the club too. Center to center is what we're shooting for, but it's hard to do a center to center measurement. So it's gonna be a top to top actual measurement. Oh, booyah. All my booyahs just went out the window. So one of the things I would have liked on this project, and I forgot it, I'm gonna check the service van, but it's putting cold galvanizing spray on the cut ends of the strut. It's just a small aesthetic. It will be required in some like spec'd projects, and that's gonna prevent corrosion from the cut ends because this is galvanized. All this stuff, it's gonna take a long time and a lot of weather for it to corrode. It'll be here in 50 years. But the cut ends, they'll soak in water. Everything's porous when it comes right down to it. It'll oxidize, it'll just, yeah. So, there goes this showpiece mentality. It is what it is. Guys, I really like this tool right here. It's just so handy. It's like it's a multi. It's like 11-in-1. It's for all types. It's hollow shank. It goes like 1/4 inch. I want to say 3/8 inch, 5/16 at the very least. Come on, all the way up through at least 9/16. It's just super handy. It's color coded for quick reference. It's got a big fat handle, so it's a little cumbersome in the pouch just because it really does take up a lot of room. But man, that big fat handle, cushion grip handle, it just means a lot of torque. So I'm dropping this baby in the description, and I'm telling you, if you don't have one, buy one now. The holes are not lining up well, so we're gonna drill them out to 5/16. The next size up, I should say the bolts aren't even fitting through the holes.
Check out.
Ooh. Oh my, I'm not even gonna be able to use that one, I don't think. You guys have met Tim, he's the EPro project manager. He's jumping in here to help me mount this because Cliff is on lunch. And he's a CrossFitter, so he's stronger than any of us anyways. Oh, my hand's hitting the... Oh. Okay, I have to... Master electrician does not mean coordinated. Those are not the same things. All right, you want to be careful when you're setting your torpedo level in there or whatever you line it up to make sure that it is level. There's plenty of opportunity for the box to not be truly square, or if your level's on the front side, for there to be a little bow in the lip of this box. So towards the back of the panel and is going to be your best bet. On top's not bad because that's the rain tight cover. So real quick tidbit about flipping panels upside down, right side up. When can you not? In this case, this is an outdoor rated panel. It's NEMA 3R. That's a code designation. It's rain tight. See this lip? The front cover comes up inside that lip. So this is only a rain tight panel. I'm gonna put some duct seal in that hole right there because I don't want a driving rain to get inside on my breaker and stuff, but this panel is rated to be outside in this orientation only. You cannot turn it sideways or upside down. In an interior application, you could turn this quote unquote upside down. It'd be real awkward with the flip lid cover coming out like this. So that's a question mark. But let's say it had a regular to the side front or cover on it. Because this breaker has side to side action, and these breakers as well, you could invert the panel. The overcurrent devices are the main reason when you cannot invert a panel. You cannot have a breaker up in the off position and down in the on position, contrary to standard operation. It can be side to side all day long, but you cannot. So let's say you could not turn this panel sideways, because then this breaker would be misoriented. It would be on in the down position, and that's a code violation. Other than that, you're fine. Flip them upside down all day long. Oh, that one's perfect. You know how to check a torpedo level? You try it both ways, and if it gives you the same reading, you're good. But if the reading is off to one way and then the other, then you know the level's bad. Mr. and Mrs. Customer, are you willing and able to spend the $5,000 that it's going to take in order to make this project beautiful, code compliant in every fashion, and durable for the lifetime that you own this home? There's a talk track. Obviously it sounded kind of cheesy, but man, that you call customers up to the plate like that. Are you willing and able to spend the money that it takes to have the installation of your dreams? I know you've been dreaming about power to your shed for your car, because before you made that,
Thank you.
before you made that $40, $50, $80, $100,000 investment in the Tesla, you thought about how you're going to charge it. And if you're going to have to spend another, let's say $2,500, depending on the situation, in order to charge that thing every night, just the way you want it, full tank. All right, and you always have to step back and make sure things look decent and reasonable. I think they do. I honestly think they do. All right, so the question is, what's this rack down here for? The rack down here is for our pipe. It's time to get our pipe in. The pipe needs to be supported and secured within 3 feet of termination. This is termination, so that rack is up. A lot of guys make the mistake of leaving this out and just kind of freewheeling into the dirt. There's not enough support right there. If that thing gets hit, it's going to break right on the threads. That's the weakest spot. I see this all the time. There's no support within 3 feet. It breaks on the threads as soon as it gets hit with a lawnmower or a kid with a baseball bat or whatever the heck happens. You gotta put that support in. Like I said, Schedule 80 conduit, because it's exposed to physical damage. Make sure you check your utility standards. 2-inch would be sufficient pipe size for the wire that's coming through here, but 2.5 inch is going to be required by the utility. That, again, is not an NEC standard. I'm going to turn my printing towards the back just a little bit cleaner. That's not code. I've got a tool ready. Sometimes these things just don't want to fit on there, and you want to be able to smack that baby right on with a pair of pliers.
Why'd you cut the bulb off? I normally like it, man.
Yeah. Boop, boop, boop. I do really always like the factory bell end, this guy here, but in this case is in my way because I've got an inside fit on top and bottom. I'm not going to glue that until I'm ready for it. I intentionally cut the pipe long enough that it's going to be 12 inches below grade in order to protect that wire from physical damage. That's a code standard. And but I am going to have to dig out a little bit more. I'm going to go ahead and strap it, but I'm not going to glue it because the guys who bring the wire out, they might not be able to shove it easily up the pipe. They might have to take the pipe apart, shove it in the pipe, and then fit it into the meter cabinet. I'm going to give them that latitude if they need it. Guys, I'm super excited about this. This wire, revolutionary. We do anywhere from 2 to 10 electric vehicle charging installations per week. We are almost always using 6.2 or 6.3 Romex. We're often in a situation like this where we're outdoors, we have a direct burial situation, we have exposure to sunlight. We've got all kinds of conditions that Romex is not rated for. You cannot bury it in the ground, you cannot put it in external conduit, and you can definitely not expose it to sunlight or it's going to deteriorate on you. So, our folks sent us this Trable cable. This stuff is super durable, and check out the ratings and listing on it. It's insane, but let me show you real quick. We've got 3 6-gauge copper conductors. We've got 1 8-gauge ground, also copper. And then listen to this. This stuff is rated for, it's tray cable, 600 volts, sunlight resistance, direct burial, joist pole. It's gorgeous. It's wet or dry, and one of the differentiators is it's 75 degrees C rated, not 60 degrees C like Romex. If you're an electrician, you'll know what that means. You can put this stuff on 50 amp breakers without using the next size up rule. You can put it on wet locations. I'm loving it. I'm loving it. Okay, so here's the one thing. It's a little bit harder to strip. Of course, it's got a heavier jacket. This is what I'm gonna do. I'm gonna make it up to my 50 amp breaker. I'm gonna run it in conduit just because it's a free rack and I want it to look real clean. I'm gonna bury it directly in the soil. I'm gonna bring it exposed up on the outside of this barn. I'm gonna make sure the inspector can see the rating in case he's got a beef with it. And we're gonna terminate it in our NEMA 1450. Absolutely gorgeous. So there's a special knife that was sent with this. It's a $50 knife. Kelly, thanks for the gift. But I don't know that I'm gonna buy all 30 electricians and apprentices a $50 knife to strip this one type of cable. So I'm gonna demonstrate to you utilizing my just regular old used blade and a utility knife. Whoops. I'm gonna want about 2 feet stripped on this end. I've got about a foot. Let's take it back a little further. First of all, I gotta show you, once you get it started and you've got that pole ripcord, you gotta be wearing gloves for this because the jacket is heavy. But you can just rip it right down, but that would be too easy. So let's bring it back. I'm gonna very lightly so I don't score the inside insulation. And then I'm just gonna try. I haven't done this, guys. I have not practiced at all, one bit. Should probably retract my blade a little bit just in case something goes wrong. See, that's not bad at all. There's so much of this insulation around the wire. That's not bad at all. I don't mind that one bit. That's easier to strip than UF cable if you're used to UF. Heck yeah. Kind of got a lot of trash to deal with. But $4.55 a foot on a 500-foot spool. Dude, this has just become a stock item at Jefferson Electric. And we're gonna be burning through 500-foot spools like there is no tomorrow. I'm super thrilled. Kelly, PO coming your direction. All right, let's check it out. We put some waterproof adhesive on the back side of this, seal up those holes. We're using an outdoor rated screw that I really, really like. It's like triple guard, super heavy duty, incredible shear strength. And not, the barn is coming down before the screws come out.
Might need a little bit.
I can guarantee that. Get your single top screw in. I'm gonna line it up in the center
Deep enough. Just not wet.
between these vertical seams. Just for aesthetics, by having one screw in the top, it's easy to then level. Ooh, you know what? The barn's not level.
Nope.
We level the unit, or do we level it to the barn? To the barn. I think our visual reference point is the barn. All right, pro tip. It's time for a pro tip. This is really, really important. When you're operating the trencher at a junction like this, you have to take it to max depth and just as deep as you can. So one, always oversize your trencher. If you're digging down to 24, get at least the 36 because they really bog down at max depth, and you're gonna have so much more success with the 36 for two reasons. One, the power associated with it. You're gonna cut faster, cleaner. Two, when you cut down at a junction like this to 36, or let's say in this case 48 when we need 36, what you're gonna do is you're gonna allow 12 inches for easy backfill. So instead of having to get the dirt out of the hole, if you're digging out a little bit, you just throw it right down into that depression, and you just literally just knock it aside into the deeper part of the hole, and boom, you got it. So PVC at larger sizes can be really, really stout. So that pipe is resisting going into fittings. So you just got to get on the end and tap on it. We are ready to.
Did you already put it in?
No, we're not going to glue it. I need to eat away a little bit more here. Get this to fit.
Probably makes it
Almost there. PVC and a gloved hand, you really just, that's all that's required. You don't have to pull out a file for that. There's nothing left on that edge that's going to damage your wire. All right, here's another tip. The strut straps. PVC Schedule 80 has the same outside diameter as PVC Schedule 40. The outside diameter is equivalent. However, the inside diameter is less on PVC Schedule 80. And so, because it has a thicker wall, it's Schedule 80. So that means that you're gonna have less wire fill in your pipe on Schedule 80. You're gonna have less room per code. Here's the other thing. These strut straps, these are STD strut straps. And that means that they're rated for a larger overall outside diameter of pipe. So you're going to use an STD strut strap for rigid, IMC, and PVC. These will not work well they will not work, period, for thin wall pipe like EMT. Ain't gonna happen, bro. So just be mindful, there are two types of 1 1/4 strut straps. There's the STD for the heavy wall pipe, thicker wall pipe, and there is the standard for EMT. If you don't pay attention to those details, you'll really be disliking yourself. Here's another thing. I'm going to insert a number 6 ground wire and UF cable into this 1 1/4, and I'm going to put 6'3" through this pipe. I'm over on fill. I'm going to exceed NEC standards for pipe fill on purpose. You know why that is? Because this is an incomplete conduit system. It starts in a fitting, that side's complete, but it ends in free air, if you will, right now. It doesn't end in a junction box, a definite point. So this is an incomplete conduit system, which means I'm not bound, Chapter 9, by pipe fill. It doesn't apply here. So I'm going to cram a 6'3" cable in here. I'm going to use that because it's a straight run, probably 65% of the inside area of the pipe. That's far in excess of the NEC standard, but it does not apply in this circumstance. All right, we're bringing in some provisional power. This is a 10-3 UF cable. Take a look at that right there. It's a molded cable. It is not nearly as durable as this beautiful tray cable. It's harder to strip, but it's got 3 10-gauge conductors plus a ground. And I'm gonna slip that in to my conduit here. And that's just provisional from the panel to the shed while we've got the trench open. This will handle anything Sean's got going on in there. If he wants a little heater because it becomes a potting shed or a hobby shed, if he wants to put a little tack welder, a kiln, this will do that. So that's what this is for, strictly provisional.
Is that a good spot for it?
All right, some of you are gonna rag on me that there aren't bell ends on these two fittings here. It's pretty, I know, go ahead, rag away. Should be bell ends on there, but I didn't have any bell ends. Guys, it's smooth. I'm gonna try to be careful. No bell ends, okay? Once again, thank you. Teamwork makes it really quick.
Sorry.
No, you're good.
Everyone in the UK will know what a bell is.
Why is that?
My red stuff.
That's it? That's it.
Bell ends like an idiot.
Oh, okay. Let's go ahead and lay that wire in the trench. All right, now here's the deal about grounding in the state of Indiana. 2 ground rods, more than 6 feet apart, no impedance test, that's it. Generally speaking, 25 ohms of resistance or less by means of a ground resistance tester is required by code. But in Indiana, they've said no testing, 2 ground rods, no exceptions. We're not having our electricians or our inspectors carrying around test equipment to verify. The soil type we generally run into, 2 ground rods or less, 2 ground rods 6 feet apart or more is all that's required. We're gonna bond with a number 6 ground wire. That's code, table 250.66, with the exception for rod, pipe, and plate electrodes being in play. So it would be a number 4, exception comes in, it's a number 6. That's corresponding to a 200 amp service and the maximum that these ground rods, the max overcurrent that they can dissipate. We're gonna go ahead and utilize the trench we've got open to drive these ground rods. This is an excellent location because you want your ground rods, I'm yelling at you guys again, aren't I? You want your ground rods to be in a place that's going to have be permanently exposed to moisture. So you don't want the ground rods to be underneath an overhang. If there's an eave side of the building or something, right here we're wide open, clear skies. So I'm going to take the pointy end of the ground rod. Woo. Flip it over. I'm going to drive it into my trench because effectively I've already got 3 feet of burial when I start right here. I'm going to put the first one right here. Make sure it stays out of way of my wire. It's going to be buried. I'll go ahead and drive what I can by hand, which is pretty good. And then I'm going to finish it off. There are a couple tools I really like. Top tool, I don't have it with me, guys. I'm not really equipped to be in the field every day. I don't have my own service van, but it's an SCS adapter. I'm going to drop the link for Amazon into the description. You put it on the end of your SDS rotary hammer and you just done. The second one is a ground rod pounder, and third, least favorite, I'm going to be demonstrating for you is the sledgehammer. Be careful. So many injuries have happened driving ground rods. It's just more dangerous than somebody might give it credit for. One of my guys chipped his kneecap. Ouch! When you're coming wailing down on a ground rod and you miss and you chip off the edge of your kneecap, oh my, he limped for 6 months. No exaggeration, be careful. Hey, we are, time to terminate our conductors. It's a little muddy around here. Whew.
What did you just tuck away there?
All right, we tucked our provisional 10-3 out of the way. We are now terminating our NEMA 1450 wire. Remember, grounds and neutrals are common. I'm going to just go ahead and keep the full length on my conductors because this panel is not congested. I don't anticipate that it will be for a long, long time because it truly is dedicated for electric vehicle charging. Per the utility agreement and that fantastic 2.3 cents a kilowatt hour that we're going to be taking advantage of for off-peak charging. So effectively, when we charge the Tesla, and this is the company Tesla at Sean's residence, when we charge it between the hours of 10 p.m. and 6 a.m., which is plenty of time for a full charge, empty to full, what we're going to be doing is paying 2.3 cents a kilowatt hour. That's crazy. That is 1/6 of the utility rate here. And that we're cheaper than most places across the country. We're like the cheapest out of the top 20 cities. We're crazy cheap. and we're paying 1/6 of the crazy cheap rate to charge that vehicle. And a Tesla Model 3 has a 126 mile per gallon equivalent. It's crazy. It's just crazy. Guys, if you're an apprentice and you're watching this, all the respect in the world to you. Keep working hard to advance your career. It's going to pay you dividends. And I'm going to recommend to you not just ingesting our content, but also go to school. Your employer should pay for that school. Go to school, advance your career, knock it out. You know what? Sometimes if you're a sharp guy like Cliff, the classroom moves pretty slow for you. Not everybody there cares. Sometimes it can feel like a waste of time, but at the end of the day, it will be what you make of it. Advance your career, get your license, create some earning power for yourself and your family. If you're a sharp guy, you can be making $100,000 a year at the end of 4 years, debt-free, working as an electrician. That takes a pretty talented, motivated individual, but it's possible. All right, we're landed in here. We're not gonna be able to test power because the utility's not gonna energize this for a matter of weeks, probably, maybe even months. So we're going to go ahead and put the inside covers on, outside covers, seal it all up from the elements, let the glasses defog. Oh, we've got our grounding conductor, our electrode grounding conductor. I still gotta terminate that, it's hanging right here. Here it is. You could use number 6 solid, number 6 stranded. You could use coated or bare. In our jurisdiction, all are permissible. You're going to want to use, here's the biggest thing, you're going to want to use one continuous length of conductor. Don't splice conductors together. That might fly in some jurisdictions, but it's not best practice by any means. So what we're going to do is we're going to shove it down either conduit, doesn't matter. Woo. It's a little bit stiff. Here, you want to shove it? I'll jump down in there. You got 2 football clamps, I think, right over here. There it is. All right, I'm sure that's plenty. Thank you, I was just hesitating. Is it? Yeah, drop it on in there. Boom. Awesome. All right, so I'm gonna strip back a midsection right here. Use my utility knife. All right, so I've got my bump cap on today. Man, I love that thing. Fits right in there. It's not a hard hat, doesn't comply, but it sure is nice. All right, what I've done is I've stripped back the conductor about a total of 2.5 inches with my utility knife, tucked it in the back side of the clamp. If you are a Jefferson apprentice, listen to me right now. Back side of the clamp, use a 1/2 inch clamp. Watch out for 5/8 here, 1/2 inch ground rods. If you've got some kind of ground cover that you're penetrating through, sidewalk, asphalt, etc., you're going to need to use the next size up ground rod, 10 foot in length, so that you actually get 8 feet of contact with the earth. In this case, we're going to get a true 8 feet of contact. We're going to be all buried, and my grounding electrode conductor, that's this wire right here I'm installing, it's continuous. This is my grounding electrode, that ground rod. It's a rod type grounding electrode. Continuous wire, tighten it down. This is a brass fitting. You will split the bolt if you just crank the heck out of it with your channel locks. So get it snug to where there's no longer any movement in the conductor and leave it alone. Even if it slides down the pole, I think I'm toast. Very little room to maneuver here. It's tedious. Might have to get out the ratchet. I would not use a power tool on this maneuver. Too much torque, I think you'll break the fitting. I'm really hoping the guys who drop the cable in here are conscientious. We've got plenty of slack on our wire, so it's not going to get yanked loose if they just kind of throw it in there. That ground rod's pretty obvious. If I had some flagging tape, I'd probably flag it. Those guys are utility workers. I don't know that they care. Not all of them, that's for sure. I'll tell you what, electric vehicle charging in and of itself is relatively competitive if you don't sell the add-ons. I'm going to tell you what the add-ons are. I'm going to tell you how much to sell them for, and I'm going to tell you what they do for your margins. So you may not like it, but I've done it again. I don't have a 1/2-inch mini. I don't have a 1/2-inch strap. So I've created a splint, and I'm struggling with my splint a little bit. It's definitely not time efficient.
Well, there's a screw there.
Better just to have 2 1/2-inch straps and make it beautiful.
Prevents the cover from,
Yeah, you gotta.
What? There we go. All right, we're not going to backfill anything. All of that's taking place tomorrow. After the utility company installs the cable in the trench, the utility company is responsible for installing the cable, terminating on the line side of the meter, and building the riser at the pole and making connections there. So at this point, we're going to put a self-certification tag in that meter base. That's an attestation of our license, our inspection, our liability on this project. The utility company is going to see that. That's their green light to hook it up. If something blows up in their face, I'm on the line. It's an interesting looking terminal. I don't think I've used this product before, and I'm just an okay fan of it. It is NEMA 3R. It's relatively cost effective. It's not the heavy duty kind of outlet, but it's integrated into the faceplate. So it is NEMA 1450, but it's not truly the $100 industrial grade version of plug. That higher grade version is rated for a huge number, like 10,000 insertions and removals of the plug. It's probably not going to happen here. I'm guessing the charger, it's pretty protected from UV degradation, is going to be permanently hung on the holster, which I'm about to show you right here. So I'm okay with this. It's not typically the one we sell though. All right, so we got the grounding connection made in the back of the box. You bring your equipment grounding conductor in, land it there, and then the pigtail comes to, or the jumper, grounding jumper, to your plug. Now I've got 3 more conductors to land, and I'm just gonna crank it. They're all labeled. There's, oh, I think that's white. Okay. I think the design is that you split the conductors. It's really an interesting terminal. Split the conductors in 2. Thanks, headlamp. Whew. On demand. There we go. That helps. It's almost there. Okay, number 1 is in. We're gonna wiggle, tighten, loosen, tighten, wiggle. Without stripping the terminals. That's the trick. Okay. So weird. So what would happen if I tighten it up? No, that is how it's designed. That's weird. It's a very interesting terminal. So I decided to take the ground off. That was factory connected. I just need to get this plug out here where I have a little more room. I can stand up, So, back to it. Gotta split this conductor in the terminal, wiggle it in there. Got a replacement screw here and it's pointed. I don't want it going into my work, so I'm gonna cut it short. I don't need much from it. And, oh, this is soaked and slimy. Oh. The whole thing's a battle now, folks. We're down to the battle zone. Everything's wet and slimy. Resilience is fading. So is the sunlight. No, that's an exaggeration. Okay. Fair.
It's a dark night in the soul.
There it is. All right, guys, this is how you make money on electric vehicle charging. I'm gonna stop blinding you with my headlight. All right, so the base project for NEMA 1450 and an easy installation. I'm talking like panels in the garage, outlets going directly below the panel, garage is drywalled, using industrial grade outlet, $100 right there, remember, don't forget that. You're gonna be at about $500 flat. If there's a permit required, you're gonna have to mark up for that as well, $150 at least, depending on the cost of your permit and the difficulty of pulling that permit. So you're gonna be at $500 to $650. But,
Or double the.
start thinking upsells. If I was a homeowner and I had a NEMA 1450, what do you do with your plug when it's not plugged into the car? You just leave it in the mud? The mobile connector is what, like $300, $400? No, you're not gonna leave it in the mud. You're gonna wanna hang it on this nice little mounting hook. I'm gonna put the mounting hook right next to the NEMA 1450. It's gonna be great. And you can buy this for $26 online. I personally think this one's a little bit better than the Tesla version. Link in the description. And you're gonna charge $75 mounted on the wall for a 26, I think it's 26, 25, 2016, 15, whatever it is, dollar unit. You're gonna have a margin on that. And then you're gonna talk surge suppression. Surge suppression is vital. You just spent 50 to 100 grand on a new car and you don't wanna protect it from surges when it's plugged into the electric grid. Oh, that's your prerogative. So throw a surge suppressor on there, protect that sucker. Yeah. So you just took a $500 job for electric vehicle charging. And you just turned it into a $1,000 job with these two add-ons. You throw in some marked up drywall repairs, you throw in some kind of inspection, electrical panel inspection like we talked about in another video for $141.50, and you turn a $500 job with legitimately added value to the consumer into an $1,100 job. Now you've got a full day's work, boom, rocking and rolling. You can do that in 3 to 4 hours. $1,100 in 3 to 4 hours. We do that all week long and we love those jobs. Use a stud finder, mount it in the stud if you're putting in drywall, because that thing's gonna yank out of the drywall, even if you use mollies or toggle bolts. So don't be cheap about it. Your reputation's on the line. Boom, snaps into place. Nice compliment. We'll make sure that cable's straight when we backfill. Actually, Sean will, he's gonna backfill. Gotta label everything. And document everything using company cam to take all my pictures. I've got panel brand, I've got completed work, I've got grounding, whoop, I've got the trench, I've got the depth of the trench, I've got everything that I could need. If an inspector walks along here and says, hey, how do I know you had the trench at proper fill? I'll be like, boom, company cam, permanently logged, I've got evidence, take a look. And I can easily export those photos to him. So, feel pretty good. Now, I wanna leave you with some information on this project. The material on this project, about $1,200 before markup. That's our cost. Compliance, about $200. That's permit and tag. Labor, about 21 labor hours. By the time you mark it all up, I'm calculating that this project, although it's an internal project, the retail for this project would have been $4,436. $4,436. There it is. You've got my numbers. Comment below if you think that's cheap, if you think that's high, if you think I didn't go about this project pricing it up in the right way. We're setting a market. Every time you price a job, I price a job. We set the market rate. If we set the market too low, we don't attract talent into the trades. We don't create a career path and a future for electricians. If we set it too high, it's unethical and it becomes fraudulent at some point. So we've got to set a market that's reasonable. Consumers want professionalism. Subscribe to Electric Pro Academy for real skills to make real money.